Yeah, did you start the recording, Akshat?
I did.
Right, okay. So, just a sec. So, today, like, mostly we'll be going over hardware stuff. And so, yeah, for those who don't know or haven't visited here, so this is our C5, and this is our workspace where we'll be working. And here you can see the new academic complex, and all this is the area surrounding. So, we'll just quickly go inside. And so, yeah, so this is like, so we have a couple of things arranged over here. We have a couple of things arranged over here, and we'll be showing you like what all things we have and how all of this works. So beginning first, I think we should introduce you to our workspace. So currently FIFA is under some renovation work. So we used to have our workspace in this region over here, but right now it is being shifted to this side. And so we deal with drones and planes, as you all know from before only. So first of all, this is one of the drone. We'll get back to it later. And here we have our inventory. So these are some of the flight, the transmitter receiver pairs over here, and some tools general. We have our motor box over here. So as you can see, we have a lot of motors lying around and some screws. We also have an Raspberry Pi over here. Then we have some camera equipments which are like gimbals and all, which is used to like rotate the camera according to our needs. And we have some tools over here. Moving on, we have many propellers which like different shapes and different sizes. Then over here we have the batteries, varying from like small, from like this size batteries to this size batteries. So this is an 8000 mAh batteries, which is 6 cell, and this is like a small 3 cell battery. And all these are like lipo batteries. We'll come to it when we explain the working of the drone. Then we have the bottom shelf stuff. We have kept it on a table, which will be like which has the drones and all. Moving on, here we have some of the old drones that the club had. So these are like this drone was used in the Inter IIT Tech Meet 3 years back, and all the electronics have been stripped off because we reused them. So that is why there is nothing over here. We have a ready-made like working drone over there, so we'll be showing you that as well. Apart from that, here we have our ESCs. So ESCs are electronic speed controllers, which Ayush will be explaining later. And this is how it looks. Uh, Also, for those who don't know, we'll have a session regarding drone building soon after. Then we have another battery, some quadcopter parts, and some carbon fiber rolls. Then here we have the video transmitter, which is used to like transmit video from a short range to a very long range. Then we have some servos lying around, and servos is like you can use different orientations using different signals. So that is how it works. We have a flight controller, which which is Ardu copter. It is called APM. So as you might know, we learned Ardu pilot using in the summer school, and so this is the flight controller that uses Ardu pilot. Also, Pixoc also uses Ardu pilot, and but it's more compatible with the PX4. So that is why we'll be using. We use PX4 because it is easier to use. Then some more batteries around here, and finally at the bottom we have some packed stuff, which is also some miscellaneous quadcopter parts, and we have wooden propellers right here. which were used in the IC engine plane. And moving on, here we have a really big drone. So you can see, like you can compare the size of the drone. So this was basically used in a prototype of an agri-copter project that was done, I think, 1 year back. So this is approximately like, let's say, half a meter long, or even more, I think. Also, like all the electronics have been scraped off because they were used. And so, yeah. Okay, now moving on. Here we have all the previous like old planes and all lying, and these are some of the wings that we made in, I think, January. And so here comes the temporary table that we have. And apart from that, now we have an old, very big model of a plane lying around. So this is the plane that was there, and this is, I think, about 3 meters wide, and it did not use any electronics and stuff. This was used with an combustible engine, and the servos and all were controlled by a pneumatic mechanism that is pressurized air. So that is how this was worked. Now it is not in a working condition because it is like very old and the parts have become rusted and stuff. So yeah. Now moving on, I think we'll go to the working of a drone now. So just I'll be back in a minute. Right. So moving on now, this is like a complete assembled quadcopter, and this is how it looks like without a frame. I think it will take time for the video to load. Yeah. So I think it is visible now. Yeah. So this is how a completely assembled quadcopter looks like. Of course, this is a very advanced model, but yeah. So starting with the very basic. So this is a quadcopter frame, and this is how it looks like. So all the electronics go on this part, this and under this. The battery is attached either below or either above it, and these arms or this part will hold the motor. So the motor will be mounted over here like it is here. So the motor will be mounted here, and all the wiring will go through this arm into the center over here. And we'll show you the wiring process also. And also, as you can see below this, this board has certain electrical connections made. So these two things you can see. So this board can be used as a power distributor board. So when we come to ESCs and all, so the power is inputted from here and it is distributed to all four corners over here. One, two, three, four. So that is how all the motors get power equally. So this is a basic drone frame that any quadcopter uses. Now after that, this is how a motor looks like. And so this is our brushless motor, also called as BLDC. And so there is a rating written over here somewhere. So yeah, this is an 850 kV motor. So this is nothing but okay. First of all, it is not kilovolt for those who are confused, and this is a 850 kV motor, which is like a power indication of motor. Also, the brand is Avionic, and okay, so the motor. Okay, yeah,
Yeah. So the way a BLDC motor works is that you can see that this has three connections over here. I can just move that here. So yeah, this has three connections over here. So these three connections are basically three-phase EC. So like one will be at 0 degrees, one will be at 120 degrees, one will be at 240 degrees. And so these three are at that constant pace, and so you can control both the voltage and the current. So basically, when you control the voltage, it controls the speed of this thing, how fast it rotates. When you control the current, you control the torque of how powerful the rotation is. So that is basically how these are controlled. Now, a very good question would be that how do you convert a signal from a battery, which is usually a DC, to this sort of three-phase AC, and and so that you are able to control the current and the voltage in such a way that you can control the RPM and the torque very well. So for that, the next part comes in, which Pranit showed earlier. It is an ESP. So ESP is electronic speed controller. So these are the three leads of an ESP, and it does not. Okay. So right now it doesn't matter what order I plug them in. So any one goes into any other. But really, if you want to reverse the direction of the flow, okay. How about a guess? Like, let's say that we have this ESP connected like this. This ESP is giving the three-phase AC signal, and the ESP is connected to the battery from this place. And like right now, let's say this is rotating clockwise. So, I want you guys to maybe put a guess in the comment section. If we want to make this go counterclockwise instead of clockwise, what do we do? What do we change in our wiring? There can be multiple correct answers. Okay, I can't see the chat. Okay, so never mind, we'll only do. So if you want to reverse the flow, just change any two. Like you have three connections made here, right? Not just human. So just switch any two, and the direction at which the motor is rotating will be opposite. Right. Okay. So that's that. Then the next part we'll come to is the battery. Where's the battery case? Yeah. So this is called a lipo case. So we use lithium polymer batteries. So lithium polymer batteries are actually very dangerous. And if you've been following the news, then there have been cases of lithium batteries burning in electric scooters all around India. So we store them in these special cases called lipo cases, and these basically make sure that they don't burn, and if they burn, it doesn't spread along. And so this is what a lipo battery looks like. Okay, I'll give you a better looking one. Okay, no luck. So anyway, this is what a lipo battery looks like. So these two leads are the power leads. So these will give you the power. So if you saw our ESC earlier, uh, okay, yeah, here. So our ESC had these two entry cables in it. And so these two entry cables of the ESC can be plugged in into these two cables of the battery, right? And then one thing, okay, you have it powered on, but how do you control the speed? How do you control the current? Like I said, voltage control is RPM, current control is torque. So that is done through these wires. And these wires will basically be connected to your flight controller. For now, let's just say that anything that's controlling your plane. And that will basically control how much current and voltage comes out of this ESC and into the that thing, into the motor. Real motor. So this is the lipo battery. So this is a 6 cell battery. So we have written that over here. Usually they are better branded and they have like a nice caption and everything. We basically broke this one and taped it up again. So right, that's our power thing. So right now, just a small recap. So the power comes from a motor, from a battery like this, right? Then it goes into this board, and this board, if you remember, had these inbuilt connections, these things. And so these things distribute that power into each of the ESCs, electronic speed controllers, and the signal wires of the ESC basically, the other wires except for the two fat ones, those go into our flight controller, and that's what controls our speed of the motors, everything. So right now, Ayush and Pranit are showing me something.
Right. So how this works is, these are the ESCs So you attach, like every arm should have an AC, and so AC has like a positive terminal and a negative terminal. So if you look closely on the board, you'll see one minus sign and one plus sign over here. So how this works is you put the minus over here and you put the plus over here. Like obviously in real life you should not touch this. We don't have any power running, so I'm doing it. So and you solder these 2 points over here. And then if you have your battery like this, okay, yeah, this is how a good battery looks like. So it has all printed stuff, 5200 mAh, 4 cell, and the number of volts. So I'll use this battery for now. So you connect from here, you put power to this point, and this will distribute it equally into all the four arms. So you attach your AC here, and you attach your battery over here, like all four ACs and your battery. So each of the AC will be receiving equal power. Now, once your AC is attached here, you can either zip tie it here like that, or you can like put it, yeah, or you can like put it inside here if you have more wire. From here, these three pins, as Akshat said, they go to the motor. Yeah. So this is a motor. It has some stand on it because it was scraped off from an old quadcopter. But generally, you can just attach the motor over here. This side will be up, and the circuit board is on the bottom. So you'll attach the motor like this, and these three pins will be attached onto the ESC. So if you look closely like that, the motor will be here, and the three pins will be attached onto the ESC wire, which is coming from the power board. So that is how you make the basic connection. Yeah.
Right. So now we'll move on to like the brain of our system. So, like we said, that there's something that is controlling that current. There is something that is controlling the drone, and we don't essentially want to have individual control for each meter, right? We want to be able to give some high-level commands, and then it will do what we want to do. So for that, we use a flight controller. And right, okay, so so apologies for this. We didn't take the flight controller out, but this is what a flight controller basically looks like. You can see the word fix off written over there. So this is our flight controller, and basically all of those individual wires go into the terminals, and there's something over there inside the switch. And you can also connect like your GPS. This is a GPS. So GPS is basically what's on your phone, but a lot more accurate. So you connect your GPS, you connect your lidar. We explained what lidar was last time. All of those things into your fixed and your flight computer. So the flight computer looks something like this. Can you show that perfect? Can you get that? Yeah. So we connect all of these, and with that, we are able to basically control the drone and use the pieces of software that you guys have been using, like ROS, Node, ROS, everything. That is all used through this controller, through this computer into the flight controller. And okay, so one thing about this particular computer, I think Ayush will be able to do this.
Yeah, so the computer which you can see is this is a Jetson Nano, and this contains like Ubuntu operating system, Ubuntu 18.04, and it is a 4 GB RAM system. And this basically can run ROS, like it can run variety of ROS nodes and ROS office along with OpenCV code. And also we have connected a camera to this. I think you'll be able to see this is the IntelliSense D435 camera. So like this can do pose estimation. This can also calculate the distance between 2 points. It also has an IR camera, and as you can see, like this is also connected to this, and it also has a Wi-Fi module. So thing is, this Jetson was bought in 2018. So back then they didn't have like Wi-Fi built into this. So we have attached like an external Wi-Fi module here, and even like during that time C type wasn't that much popular, so this has a B type powering mechanism. However, we have created like a 5-volt converter to power it as and when like we power when we power the Pixel with the battery. So basically what happens when you power the Pixel with the battery, um, this also gets powered up, and this using the barrel jack will power up the Jetson Nano. However, if you just don't want it on a drone and like you just want to and like install some software or just like explore just the Jetson Nano, what do you do with okay, so this yellow colored thing you see, it's basically like a jumper. Like um, this will basically like change the so right now this is getting powered up from the barrel jack. So once I remove this, this circuit is broken. Like now you can only power it using this B type cable. So with a computer, you can just use a B type cable and power it. But when you're using it on a drone, it's better to power it using this converter. And yeah, and yeah, Pranit will continue.
Yeah, so I just found a flight controller which we weren't able to show you. Uh, yeah. So here is a Pixoc. So this is like a flight controller that you use. And as you can see, there are a lot of things written on the top of here. So you can attach, let's say like this is the GPS port. So you can attach a GPS on this. And even if you see here, so here like there is an I2C attached, and here there is a USB attached. So that is how it works. So this switch is a safety switch, which will come to like at the end when we'll start the drone for you. And buzzer is like an indicator if there is some error or something. Yeah. So now these pins, these are a set of like three pins, and if you see on top here, is it visible properly? Yeah. Here you can see aux out, and here this is main out, and also at the corner here, is it visible properly? Right. It is not coming in focus, but there is S bus and there is RC in. Okay, so I'll just briefly tell you what each of these pins does. So these 1, 2, 3, 4 from the middle, these pins. So you attach your ESCs over here. So, so your ESC has like these three pins. This is one pin that we didn't explain you in the ESC. So basically, this goes into your Pixoc in pin number like corresponding from 1, 2, 3, 4, and the proper way to attach this is there is written S plus and minus. So if you see your wire here, so your the black is your minus, the red is your plus, and the yellow or the white would be your S. So S is nothing but the signal. So this is how you will be attaching your just a sec. Yeah. So this is the correct way to attach your ESC wire into the Pixar, and you just plug it in the corresponding ESC and which motor it corresponds to. You just put it in there. Moving on. So this is a Raspberry Pi. So this is nothing but it is just like what Ayush explained. It is like a Jetson Nano, but it does not have GPU like graphical processing power. So that is the only difference between Jetson Nano and Raspberry Pi. Even Raspberry Pi can be using Ubuntu, or it can use its own operating system, which is called the Raspbian. I think many of you might know about it, or many of you might have even worked with Raspberry Pi. So this also you can connect directly to Pixoc, and whatever things we were doing on Ubuntu, except the gazebo part, all of them can be done on the onboard computer like this, or it can be done on the Raspberry Pi like this. So that is why we were learning all the stuff so that we can implement it on a real life one. Now moving on. Uh, okay, so coming to this drone. Now there is a thing about this drone that this did not have a power board underneath it. So here you can see this board, which is like which has all the red and black wires. So that is basically our power distribution board. So we did nothing. We just took the battery and divided into four equal powers and supplied the ESC's power. And if you look on the top side over here, I don't know if it will be clearly visible or not. I'll just find the proper angle. Uh, okay, yeah. So you can see this thing, right? So this is nothing but this is an ESC, and there are four of such things attached. Okay, wait. Yeah. So this thing here is an ESC, and there are four such parts attached. I know it's not clearly visible, but that was just for explaining purposes. Then in here we have our Pixop, this black thing right here. This is our Pixop flight controller, and if I show it from the other side here, so yeah, this is the pins section that we had, and you can see we have attached four pins for each corresponding to four motors, and this is how we connect it. Then so we have so far we have covered the frame, motors, ESCs, and the flight controller as well as the onboard computer. One more thing, this thing right here, this is nothing but a power converter. So generally we use a 4 cell battery when we have four motors to work with in a average sized quadcopter. So as you can see, the voltage here is 14.8 volts. But the specifications of this computer, you need 5 volts to run this. So this converter converts it into 5 volt, and then from here, like the wire, this comes from here and this goes into the barrel jack here. So that is how it works. Oh. Next thing, this small thing right here, this is a receiver. So this will receive the input from your transmitter, which is this, and it will give it. This is also connected to Pixoc. I'll just show you the last three wires which you can see over here. This is nothing but this thing. So RC in was the channel that we talked about, and this is how it works. Moving on to this is the GPS, and it is attached on the GPS portion of GPS pin of the Pixoc. I think I lost it somewhere on the table. So there is a GPS pin on the Pixoc, and that is where it goes. This right here, this is the transmitter, and this not only has throttle, this is yaw, this is pitch, and this is your roll. So these four sticks are just the basic control. Apart from that, what we have is we have switches right here. So these switches are programmable and you can use them for any purpose you want. Mostly this pin right here, this is used for changing flight modes. So we learned about stabilized flight mode and we learned about auto flight mode and guided flight mode. So you can program this like when I do this, so it will go to auto flight mode. When I do this, it will go to return to launch. So if you lose your drone while flying something, you just put this down and the drone will go to return to launch flight mode and it will come back to where it took off. And these things you can attach to like servos. If you want to drop a payload or something, you can uh, push this so the payload can be dropped, and all these switches are programmable to whatever function you want. Apart from that, you have your trimming here. Trimming is like if you ever had a drone or a small RC helicopter and you fly it, so even if you give just the throttle, it will go to one side or so. So if you want to correct that, let's say a drone is going towards the right, so what you do is you just increase the left trimming, so automatically it will get increased left signal, so it won't go right. So that is how it works. And also you have some adjustable like rotators or channel maybe, yeah, dials or that you call. So you can adjust maybe like anything you want. It depends on how you are using it. And so I'll switch this on. Also, this is like an X7 Taranis Q, and this is, I think, it costs around 30,000 or something. Uh, yeah, Aero Club does have that much money. So I'll be explaining you some basic features of this. And yeah, so here you can see this is Tech 2. Is it visible properly? Yeah. So this is a this one can hold like 50 types of different receivers on it. So we just have a Tech 2, and here you can see the list of all the modes that we have. It's out of focus. Wait. Yeah. So that is how it works. Apart from that, now to arm your drone, what you need to do is you have to hold the stick on your bottom right. So when you do this, your drone will arm. arming is nothing but it gets ready to take off or the fan starts spinning in a small way. Now we'll just show it to you. Just 1 second.
Okay, just one sec. We are having some issues switching the camera. Can we show them front cam? Okay, this is very strange, but yeah, we can't invert the camera basically. That's the problem. That's the okay.
Okay. So here we just plugged in the battery. Just a second. Is it visible? Yes. Okay. So we just plugged in the battery over here, and so we have attached here LEDs over here, green for the front and red for the back. And Akshat, can you hold the camera? Yeah. So yeah. So I'll just arm it right now. So you can see the motors are spinning now. You can show this one. Yeah. So I just switched it off. Now this is how you arm. And now if you want to give throttle, you can use your stick. So I'll just arm it again. And I don't know if it is audible, but I increased the throttle. So now the motors are spinning faster than usual. And you can use your sticks to like maneuver. So that is how like a transmitter receiver works. Yeah. So I think that is pretty much it about a drone. So if you guys have anything to add or anything to ask us, I think this is the time. Because now next session you'll be working with a real drone. So yeah, you can ask all your doubts. Obviously, we'll be covering this again in that time, but yeah, I think it is a good time to ask anything drone related if you have any doubt, or even if you want to know like how we'll implement all that stuff over here, you can ask us that too. Anyone, anything? Also, we are ending today early because, as some of you might know, the 20 batch people have their internship tests from today. So that is the reason we are ending early today. And about the planes, I think we'll have a separate session on that too. And yeah, so I think it is time to conclude. If you guys have anything to ask or add, so you can just unmute and speak, or maybe even type in the chat, or else I think we'll wrap it up right now. Yes. So about the onboard computer, just a minute. Yeah. So let the video load. Yeah. So this thing right here, yeah, this thing. This is like a Wi-Fi module. So even some of you might be using this, those who don't have Wi-Fi in their old laptops or something. So this is what we use to enable Wi-Fi communication on the onboard computer. So yes, it works on Wi-Fi. Yeah. Anything else? All right. If nothing, then I think we can wrap it up. So yeah. All right. Thanks for attending. And the next session will be our final session, and we'll let you know what we'll be doing. And also, you'll get like a small task which you'll have to submit in 2 3 days. So yeah, all the best and thank you.